Now that we've looked at the profit maximizing condition of a perfectly competitive firm, the question that we're left with is, does the firm ever go out of business? And this question will be answered by looking at 3 different graphs to nicely understand the implications of where the price stands with respect to the different cost curves and whether we should stay in operation, shut down immediately, or shut down in the future. So this is what we're going to be looking at. The graphs I will be making will be linked to the slides that you have, these 2 slides here, but I'll be setting it up on one slide here. I'll have them all side by side to make it as obvious as possible to understand. So I'm going to set up 3 different graphs just to keep them a little separate. Otherwise it gets a little crowded. And these 3 different graphs, as best as possible, I'm going to set up the same cost curves. So roughly the same kind of, we're dealing with the same business, but the same business will be facing 3 different possible prices. Okay, so just try to draw these as best as possible, as similarly as possible, all 3 of them. And as always, you always want to label your axes. So up here, it's always going to be price or $sign. I either put one or the other, it doesn't really matter. And here's your quantity, and it's quantity of output. I'll just write quantity for these 2. All right, so let's add a price to this. I want my green color, so let's add different prices if I want to fit with my slides. P1 will be up here. P2 will be down here. And P3 will be over here. 3 different options that I will be looking at and looking at the implications. So if I think about these options here, I want to try to see what's going to happen. Well, over here, if I were to maximize profits, my big condition for all 3 setups is my profit maximizing condition, profit maximizing quantity, is where marginal revenue is equal to marginal costs if I produce. Because it might be that my optimal quantity will be equal to 0, or Q is equal to 0. It's one or the other. It can't be anything else. So we're going to look at this situation where marginal revenue is equal to marginal cost. And why could I say it's this point here? Well, in perfect competition, we've learned that P1 is also equal to its marginal revenue. Here, this will be equal to its marginal revenue as well. And this will be equal to its marginal revenue as well. So all these 3 points where this marginal revenue, based on this price that we're facing, intersects with this marginal cost curve, will yield the profit maximizing level quantity if we choose to produce. So I could find this point here and say this would be my quantity, this would be my quantity, and this would be my quantity if I choose to produce. Then afterwards, I want to see, am I making profits or losses, and how is that set up? Well, we saw in the profit maximization slideshow and video that profit could be represented by price minus average total cost times quantity. Because price is the amount of revenue I get per unit, average total cost is my per unit cost on all of the units produced. So this is my potential profit per unit, times the amount of units sold will mean what is my profit on this specific product. So in this case here, I have to try to highlight where is my price and where is my average total cost for this specific quantity. Well, in this case here, I could think that my price Just gonna change colors here. Good thing that my price is this point here, because I see it that it's there. For this quantity, this is my average total cost. So this is my average total cost at that quantity Q1. Okay. So the distance between these two, price minus average total cost, would be my profit or loss per unit. What do you guys think? Is it a profit or is it a loss? Well, since my price, which is my revenue per unit, is greater than my average cost per unit, this would be a profit per unit. And then if I were to think what would be my total profit, it would be this whole area. Yeah, I'm just going to pause here. The thing you have to remember is this area has to be a rectangle because this is a height and this is a base. So for some people that always wonder, is this area included this little triangle? Yes, it is. So I go all the way to keep my whole rectangle. So this, in this case here, would be a situation that this firm is making positive economic profit. And positive economic profit is a very good thing because we're making above normal profits even though the owner and everyone else is paid their right amount, because we take into account all different types of opportunity costs. So this is our first scenario. What happens in this second scenario? What would happen if the price would have been a whole lot lower? Well, in this scenario here, we have a situation where our price is down here and our average total cost would be up here, which would mean that we have a situation where we have this distance between the two, between my price and my average total cost. In this case, am I making a profit or a loss? Well, if I look at this here, you can see this is my cost per unit. This is my revenue per unit. So this whole area here will be a loss. So my profits are negative in this case. Okay, I'll come back to this example in a second. So here I'm making positive profits. Here I'm losing money. And here, what's going on? Well, I have for this quantity here, my average total cost is this amount here. Once again, average total cost is greater than my price. So once again, over here, I am making losses. Here, should I shut down immediately? So between these two situations, I have a situation where I decide whether I should shut down immediately or not. So in both of these situations, I'm making negative profits, but should I shut down immediately? Okay. So if I think of this example here, well, this is the situation where if I hire an extra worker on a given day, I don't have any extra revenues than the day of work because I cannot even cover variable costs. So in this specific example here, on a daily basis, my revenues do not cover my variable costs. So to give you an example, that would be the situation that you're operating a coffee shop and you decide, should I open up, should I not open up today? And you decide to open up. And the worker that you've paid for, the coffee that you've paid for, and the electricity that it costs you, that extra cost, that extra variable cost of being open that day, do not compensate, are in a situation that they are bigger than the extra revenue you're getting in. So by opening that extra day, you are in fact losing more money. When you can't even cover your variable costs, this is a situation where you should shut down immediately. Okay? Shut down immediately in this situation. Whereas in this situation that we have here, I am making losses, yes, but if I compare my revenues to my variable costs, this would be the situation that I could hire someone to come work for me. I open up an extra day and in the day I have $100 worth of expenses based on this worker and other things, and I'm making maybe $150 worth of revenue for that extra day of work. Therefore, I am making money on that extra day, but overall I'm making losses because my rent is extremely high and other things are happening. So in this situation here, I would say to the question, shut down immediately, I would say no, because I cover my variable costs. But probably shut down before we decide to negotiate for rent and everything else. So shut down eventually. Shut down eventually. Okay. This is the situation that we have. So these are the three possible scenarios. Positive profit, very happy situation. Losses, either shut down immediately or keep operating, because if you shut down immediately, you're going to lose more money than if you keep operating for the rest of the year. So to come back to a subject that I highlighted in a previous video, was this idea that the marginal cost curve and the supply curve were linked. And I said that based on the price that we're facing, we'll have different quantities, and as the price goes up, the quantity supplied, the quantity produced by this firm goes up. That was right. However, here with this added information, where would the marginal cost curve and the supply curve be the same? Would it go straight from the bottom here all the way to the top, as I've drawn it before? No, actually it's not that long. Because over here, we saw that at a very low price, this would be my optimal quantity to produce if I were to produce. But in this specific case that we should shut down immediately, actually my optimal quantity is 0 in this case. So this does not work. This area here is not part of the supply. At this price, I do not in fact supply this quantity. At this price, I do not supply this quantity. So where would it start? Well, anywhere that I cover my variable costs will be my supply for now. And then afterwards, you could think that upwards here in the very long run might be the supply decision. But for the short run, any of these situations above the average variable costs will be situations where if I have any of these prices, I could know what quantity I will supply. Below it, my quantity supply will be equal to 0. So for this area, the supply curve and the marginal cost curve pretty much overlap.